Is it recording now?
Yeah.
Are you sure?
Yes.
Okay. So basically, no cap, heads-up displays are the coolest things ever. Isn't that right?
Yeah.
Yeah. You probably recognize them from movies like Iron Man or Top Gun, and they look pretty complicated, but the basic idea is actually pretty simple. It's essentially getting some valuable information, putting it in front of your face, and then making it so you can see right through it. Instead of having to move your head left or right or up and down to gain information, it's all in one convenient location. And that's really good for those really tense situations where you need information really quickly. Arguably, the first heads-up display was used in World War II in the form of reflector sights for fighter planes and bombers. After the war, it quickly evolved to also display crucial flight data, like your altitude or your airspeed, and even had navigation and weapons interfaces eventually. Nowadays, you're seeing it a lot more common in cars, and I think when the technology becomes a lot cheaper and ergonomic, you'll see a rise in HUDs in personal devices as well. Kind of like what Google Glass tried to do a while ago, but a bit better than that. For an RC plane, it's good to keep things simple. So the HUD design I have in mind only requires three main components. One is the observer, two is the transparent screen, and three is the actual display. So the observer can just be a camera that directly feeds video to my actual eyes. The transparent screen is just going to be, a transparent plastic screen, really low tech. And the display is going to be a really small OLED display that's powered by an Arduino Nano, which gets its data from various sensors, such as a barometer, a gyroscope, an accelerometer, and even a GPS module. So the way it works is that the display actually illuminates and has the interface that I want to see. That interface is reflected off the transparent screen right into the camera, which I will then see. At the same time, the camera can still see through the transparent screen, so the effect is that the interface is overlaid with what I'm trying to see in real life. That way I can fly the plane and get all the information I need to know about it as well. So what elements are actually in a heads-up display? Well, here's the heads-up display for an F-18, not any kind of weapons mode, and let's go through it real quickly.
First, you have your altimeter, which tells you your altitude, which is in the box. Above that, you have your vertical speed indicator, which tells you the rate at which your altitude is changing, either increasing or decreasing. At the top, you have your compass, which tells you which direction you're going in. Then in the box on the left side, you have your airspeed indicator. Under that, you have your angle of attack indicator, which is denoted by that alpha symbol, which is that loop kind of thing. Under that, right by the M, is the Mach indicator, which tells you what multiple of the speed of sound you're going at. So Mach 1 would be 1 times the speed of sound, Mach 2 would be twice the speed of sound, so on and so forth. Under that, right beside the G, is your current G-force or load factor. Under that is your maximum load factor. So within a certain time period, it'll remember the maximum number of Gs you've sustained and just let you know. At the bottom, you have your angle of bank indicator. So that just tells you how much you are rolled currently. The horizontal line in the middle, right next to the number 4, with a break in the middle, that's your artificial horizon. So in case you can't see the horizon, you can still have reference to it, so it makes flying at night a lot easier. The cross with the circle in the middle, that's the vertical velocity vector, and it's a visualization of the vertical speed indicator. And beside that, the cross without the circle, that's your true velocity vector. So in case of wind pushing you, sometimes you might not be going the direction your nose is pointing. So that just tells you where you're actually going.
Ideally, I'd want all of this for my heads-up display, but realistically, that's not going to happen because I don't think I have the technology for all of that. Or do I? Anyways, here are the things that I'm pretty confident about that I can pull off. So the altimeter is pretty easy. I have a barometer that's accurate up to 1 meter in elevation, so just plug that in. The vertical speed indicator, also pretty easy. Change in altitude divided by the change in time. The G-force is going to be pretty easy as well because I have an accelerometer and I can measure G-force from that. The max G-force, again, just an application of the G-force indicator. Angle of bank is going to be okay as well because I have a gyroscope that can give me that measurement. Mach number, I don't think I'll need because I don't think I'll be going anywhere near the speed of sound for it to matter. Fingers crossed, maybe I will, I don't know. Airspeed is the one where it gets a bit weird because with the GPS I can measure ground speed, but I can't measure airspeed. So you might be wondering, what's the difference between airspeed and ground speed? Airspeed is your speed relative to the air mass you're currently in, and ground speed is your speed relative to the ground. Did that make any sense, Parth?
Yeah.
No, like seriously, does that make any
Yeah.
sense? Really?
No.
No, okay. I didn't think it would make sense, so that's why I planned a further explanation.
These are the main questions I want to answer. What is ground speed? What is airspeed? And why does it matter? So if you already know about ground speed and airspeed, skip ahead to this timestamp and we'll get right to why it matters. But if not, stick around. So first let's answer, what is ground speed? So what I said was it's the aircraft speed relative to the ground. But what does that mean? So let's break it down. Relative to, all that means is in relation to or with reference to. So for example, if I say I'm tiny relative to Dwayne "The Rock" Johnson, that just means with The Rock as my reference point, I would be considered tiny, and so with everyone else for that matter. So now we have the speed with reference to the ground. So what does the ground mean? How can you have ground as a reference point? It's a huge object. So because the ground is stationary, you can take any stationary object and that can be a reference point. So it could be this mountain here, it could be this bridge, it could be this building over here, anything that's not moving. So in this case, let's take this mountain as a reference point. So now the speed of the plane relative to this reference point, the mountain or the ground, is pretty easy to measure. Right now, the plane is right above the mountain. Let's say 1 hour later, it's 100 miles away from the mountain. It went 100 miles in 1 hour, therefore its speed is 100 miles per hour. Makes sense, right? And that's pretty much it. It'd be the same with any other reference point. It's just a stationary reference point, gives you the speed of the airplane relative to the ground. Alright, great. So now let's move on to airspeed, which is pretty similar actually. Instead of using the ground as a reference point, you're using the air around the plane. So how exactly do you do that? Because the air can actually be moving. So let's take the simplest case scenario first, which is when there's no wind at all, the air is not moving, the airspeed is the same as the ground speed, because let's take this air molecule here. If it's not moving, it acts just like the ground reference point, and any speed measured from the air's perspective is the same as speed measured from the ground's perspective. So that's all fine and good. But now imagine that there is air movement, or the wind, as we call it, is moving. Let's take an air molecule that's moving opposite the direction of the plane's movement. In this case, the plane's airspeed is going to be the plane's ground speed plus the wind speed. And if you think about it, that makes sense. Let's say the plane is moving 100 miles per hour ground speed, and the wind is going 100 miles per hour opposite the direction that the plane is moving. It would make sense that the wind would seem like it's blowing faster compared relative to the plane. It's like if you were standing on a street and there was wind blowing in your face. If you start running into the wind is going to feel like it's blowing a lot stronger. It's the same concept here. The same thing can be applied opposite as well. So now let's say that the wind is blowing with the plane. Now the plane's airspeed is its ground speed minus the wind speed right now. And again, that makes sense as well. It's like if you and a friend were running together at the same speed in the same direction. From your perspective, your friend isn't moving at all because you guys are both going the same speed, same direction. It's the reason why you could still talk to your friend the entire time while you're running, because the friend wouldn't be getting further or wouldn't be falling behind. You'd be both moving at the same speed. So anyways, that's airspeed and that's ground speed. That brings us to the crux of the matter. For my purpose, I care about maintaining enough speed to generate enough lift in order to not stall. For that purpose, I need to know my airspeed because if you think about it, airspeed is pretty much how fast is air going over your wings. It's the reason planes can still stay airborne even if they aren't moving relative to the ground. It's because that since there's a strong headwind, there's enough airspeed to generate lift, even if the ground speed is 0. On the other hand, even if a plane is going really fast relative to the ground, if there's a tailwind equal to your ground speed, then there is no air going over the wings, and the plane will stall because the airspeed is 0. It's the reason why pilots always check the winds before landing, because the last thing you want is, as you're getting closer and closer to the ground, realizing that your lift is being cut in half by some wind at your back. Conversely, it's the reason that pilots take off into headwind, because that wind coming at them is pretty much saying, hey, here's some free lift. And during takeoff, that free lift is really handy. I know it seems like I'm hammering this point, but for my purposes, airspeed is the most important value. However, GPS can't measure airspeed because it doesn't know the wind speed or direction. So what am I going to do? Well, this is going to feel like a cop-out, but nothing. My RC jet isn't going to be flying in high wind conditions anyways, so the difference between airspeed and ground speed should be negligible. Basically, I'm just going to assume that the airspeed and ground speed are close enough for my purposes.
This is going to be a fun project. There's going to be a lot to learn along the way, but by the end, I should be better off for it. Whew! Let's do this!
Fire!